The standard model, forces of nature. By the end of this lesson, you will be familiar with the force-mediating particles known as bosons and how they interact with other particles. All matter consists of three kinds of particles. So far we have dealt with two types. We have dealt with leptons and we have dealt with quarks. In today's lesson, we're going to take a look at the force-mediating particles known as bosons. The gauge bosons in red are involved with the interactions of the four forces of nature. The Higgs boson, which you can see in yellow, is related to the production of mass. To understand how the gauge bosons work as force-mediating particles, let's look at an analogy using two people and a boomerang. When the person on the left throws a boomerang, the boomerang experiences a force to the left, while the person experiences an equal and opposite force going towards the right. Now imagine the boomerang circles back and goes to the person on the right. When this person receives the boomerang, he experiences a force going towards the left, and the boomerang experiences an equal and opposite force going towards the right. Now imagine that the two people are particles. Both of these people have forces going towards each other. The two people will move towards each other, and therefore you get the force of attraction. The boomerang has acted as a force-mediating particle, allowing this to happen. Now let's look at a second analogy. Imagine two people playing tennis, and the tennis ball is acting as the force-mediating particle. When the tennis ball hits the racket experiences a force going to the left, while the tennis ball experiences a force going towards the right. The same happens to the second person, but in the opposite direction. The racket experiences a force going to the right, while the tennis ball experiences a force going towards the left. If you imagine that the tennis players are actually particles, you can see that both of these particles have forces acting away from each other, and are therefore repelling. Let's take a look at some of these force-mediating particles now. The gravitational force is the weakest of the forces. Despite being the weakest, it actually has an infinite range. The gravitational force is an attractive force between matter, and is due to a force-mediating particle known as the graviton. The graviton is theoretical and has not been discovered yet. The graviton is the force-mediating particle for gravitational fields. The electromagnetic force acts on particles with charge or magnetic properties. It is a combination of the electrostatic and magnetic forces. The electromagnetic force has an infinite range, and the force-mediating particle for the electromagnetic force is known as the photon. The strong force is a force of attraction which occurs between protons. This is when you start scratching your heads. Protons have a positive charge and therefore should repel each other. Now remember that protons are contained within the nucleus of an atom, and this is a very, very tiny space. Whenever protons are within a certain range of each other, about 10 to the negative 15 meters, another force kicks in which is actually stronger than the electrostatic repulsion they normally have towards each other. This is the strong force. Whenever these protons are within that range, they have this attractive force. They actually start sticking together. And the force-mediating particle, which is basically responsible for this, is known as the gluon. And it's called this because it essentially is gluing the particles together. This force can only occur between the quarks within hadrons. Lastly, we have the weak force. Now, it is named the weak force because essentially it is weaker than the strong force, but it is not as weak as the gravitational force. The weak force is involved in radioactive beta decay. It acts over a short range, around 10 to the negative 18 meters. It's experienced in quarks and lepton interactions, and the force-mediating particles responsible for it are the W and Z gauge bosons. We'll explore the weak force further in a future lesson when we take a look at beta decay in depth. To summarise learning intentions from the start of this lesson, we are now familiar with the force-mediating particles known as bosons and how they interact with other particles. We know that the photon is associated with the electromagnetic force, the W and Z bosons are associated with the weak nuclear force, the gluon is associated with the strong nuclear force, the graviton, which has not yet been discovered, is associated with the gravitational force. The Higgs boson, which is a newly discovered particle, is also used in the production of mass.